You're welcome to today's class on techniques of differentiation. Differentiation is the process of finding the derivative of a function. It is the process of finding the derivative of a function. We will be looking at various rules under differentiation and how can we solve various questions under differentiation. For this class, we will be starting with what is known as the constant function rule. The constant Firstly, we'll be looking at the constant function rule. In constant function, what do we normally have? This is any question that we solve under constant function. We normally look at the answer, it will give us 0. At the end of the day, it will give us 0. For instance, if you are given, example 1, if you are given something like, given f of s equals to 8, comma, find f prime x. Given f of s equals to 8, find f prime x. This is meaning solve in first order condition. If you are to look for the f prime x of fx equals to what? 8. How do we solve this? Since we have 8 here, you say f prime x equals to 8 is here. When you solve 8, we always get 0 because it doesn't have x at the back of it. It's only 8 that is there. There is no any x there. If x should have been there, it should have been easier to solve and we wouldn't have gotten 0. It's because of the 0, the x that is missing there, that is what we normally call it the constant function rule, because it's constant, that is k equals to constant. So that is why we call it the constant function rule. So in this situation, we say f prime s equals to 0, which is f prime s equals to k, which is constant. We move to the next one, which is the linear function rule. The linear We move to the linear function rule. How do we solve question under the linear function rule? Let's look at a question under linear function rule. These are questions that will always be in form of linear equation. Then we have EG2A. Let's look. Given f of x equals to 3x plus 2 and b says what? When f of s, b says given f of s equals to 5 minus 1 all over 4x. Now, we want to solve this. Find f prime x in 2a and 2b. Now, I want to look for x, f prime x in 2a and 2b. In 2a, we say 2a. When we are solving in 2a, we say f of x equals to 3x plus 2. As we know that this 2 is constant. It's constant, which is what? Is k. It's constant. At the end, this 2 will give us 0. We are left to solve this 2a. 3x. How do we solve 3x? We now say f prime of x equals to 3x. This shows that it's raised to power 1. 1. Then we deduct 1 from it, minus 1 plus this one is 0. The constant will give us 0. So f prime of x equals to 3 raised to power 3x raised to power 1 minus 1, 0. Now, which equals to what? 3 x raised to power 0. Anything raised to power 0 will give us 1. That will be 1, which equals to what? 3. That means f prime of s equals to 3. Then we move to b. B says what? B, given f of x equals to 5 minus f of s equals to 5 minus 1 over 4 x. We know that this 5 is constant. Now that it's constant, that will give us 0. This 5 give us what we know as 0. So which is f prime s equals to 0 minus, this is 1 over 4s, which will give us 1 over 4s, this is raised to power 1 minus 1, which equals to 0 minus 1 over 4 x, 1 minus 1, 0, which equals to 0 minus 1 over 4 x raised to power 0, 1, which equals to 0. This times this 1 over 4, which equals to negative 1 over 4. Now, we have our answer there under linear function rule. This is how we solve questions under linear function rule. We move to the power function rule. Now, we move to the power function rule. How do we solve questions under power function rules? How do we solve question under power function rule? Thirdly, we have the power function rule. The power function rule. How do we solve question under the power function rule? Let's look at this. In power function rule, what you are known as is when we say power, something raised to power 2, raised to power 3, raised to power 4, and so many others. Let's look at question under power function rule. Given f of s equals to 4s cubed, comma, find f prime x. Now, how do we solve this? We now say solution. We can see the reason why we call it power function rule. We have s raised to power 3. In all this other equation, s was not raised to any power. S was not raised to any power, or is raised to power 1. But here, it's raised to power 3. That is why we call it power function rule. How do we solve this? You now say f of s equals to 4s cubed, 4s cubed, 4s cubed. That means, under first order condition, f of x, f prime s equals to, what do we have here? We have 4 here. 4 in bracket, this 3 will come here. 3, then we have s raised to power 3, then we say minus 1. The normal one we normally deduct from it, from the power, which equals to 4 times 3, 12s, 3 minus 2, 3 minus 1, 2, which equals to 12s raised to power 2. Let's look at another one here, under this one, still under the power function rule. Let's take another question under power function rule. Let's call it 3b. Question 3b under power function rule. This is A, this is B. Says that given f of s, equals to 5s raised to power 2, find f prime x. Under first order condition, now we say solution. F of s equals to 5s raised to power 2. F prime x equals to, this is 5, in bracket this 2 here, x raised to power 2, you minus 1 from it, which equals to 5 times 2, 10s raised to 10s, 2 minus 1, 1, which equals to 10s raised to power 1. That is how we solve on that. That is how we solve that. Now, the rule of sums and differences. Before we move to now we move to the rules of sums and differences. The first thing to know here is the formula. What is the formula we normally use under sums and differences? We say that under first order condition, we say f of 1 f prime s equals to u prime x u prime s plus minus v prime x. This is the formula we normally use under the rules of sums and differences. Let's take example under it. Under sum of differences, we have, let's call it e.g. for example 4. Now we say given f of s equals to 12s raised to power 5 minus 4s raised to power 4. Then we come here and say solution. How do we solve this? 12s raised to power 5 minus 4s raised to power 4. We say f of s equals to 12s raised to power 5 minus 4s raised to power 4. F prime s equals to, the first thing we will get here is, what is our u prime? Which one is u? Which one is v? The first equation, which is u equals to 12s raised to power 5, while our v equals to 4s raised to power 4. The negative sign at the middle is the negative sign we have in the formula, which is say either plus or minus. Now, u prime of s equals to, when we solve this, we say we have 12 in bracket, this 5 become a 5x 5 minus 1. The one we used to deduct from this 5, from the power. 12 times 5, 60s, 5 minus 1, 4. Then what of v? In v prime s equals to 4, this 4 will come in bracket 4x 4 minus 1. That one we normally deduct from the power, which equals to 4 times 4, 16, s 4 minus 1, 3. Yeah, we have this one to be this. Then going by the formula, which says that u prime x, what is u prime x? This is answer for u prime x. That will now be 60. That's it. F prime of s equals to 60 s raised to power 4 minus, we have minus at the middle, v prime s, which was 16 s raised to power 3. So this is what we have here. Now we move to the product rule. Before going to the product rule, what of, in these sums and differences, what if we are having both sums and differences in a particular question? How do we solve that? If we have sum and differences in a particular question, how do we solve it? For instance, look at this question which says that, let's call it 4b. Given f of s equals to 9s squared plus 2s minus 3. How do we solve this kind of question? We say that solution is having both positive and negative, but believe me, this is for this and this is for this. So now you saying that 9s squared plus 2s is u, why this is v? No. You now say, using the formula, we say that f prime of s equals to, going by the formula, u prime s plus minus v prime x. Now, what is u? U equals to 9s raised to power 2, while v here equals to 2s minus 3. Now, u prime s equals to 9. This 2 will come here in bracket 2 s 2 minus 1, which equals to 9 times 2, 18x, 2 minus 1, 1, which equals to what here? 18x. Here, v prime s equals to 2x, this one meaning raised to power 1. It means it is raised to power 1, that will now be 2 in bracket 1 x 1 minus 1 minus 3. This is constant. It is called constant, and it will therefore give us what? 0. So, which equals to 2 times 1, 2, x, 1 minus 1, 0. Then we have 0 here because it's constant. Now we can now say v prime s equals to 2 s raised to power 0, 1 minus 0 here, which equals 2 times 1, 2 minus 0 will still give us 2. Now we can now say f prime s equals to, what is our answer? 18x minus 2. We can answer, our final answer is 18x minus 2, or 18x raised to power 1 minus 2. We move to the product rule. Under product rule, we move to product. Number 5, we are looking at product rule. How do we solve question under product rule? Firstly, is to know the formula we use in product rule, which is say f prime s equals to u of s dot v prime x plus v of s dot u prime x. This is the formula we use under product rule. Now, let's see how we can apply this formula. Looking at this question, given EG5, given f of s equals to 3s raised to power 4 in bracket 2s minus 5. This is product rule. You can see 3s raised to power 4 in bracket 2s plus 2s minus 5. That means 3s raised to power 4 times 2s minus 5. This is product rule. How do we solve this? You say solution. Firstly, in our formula, we have u of s. What is our u of s here? Our u of s is 3s raised to power 4. The first thing there, 3s raised to power 4. The next thing we have in our formula, v of s. Our v of s equals to what? 2x minus 5. The second thing we have there. Now, what is u prime s? U prime s equals to, we solve this, we now have 3. This one will come here, x, 4 minus 1, which equals to 3 times 4, 12x. This is x, then 4 minus 1, 3. That will be 12x raised to power 3. V prime s equals to 2x minus 5. This one means it's raised to power 1. So that will be 2 in bracket 1, s raised to power 1 minus 1 minus 5, which equals to 2 times 1, 2x, 1 minus 1, 0, minus 0. Because it's constant, it becomes 0, which equals to 2 raised to power s raised to power 0, 1, which equals to 2 minus the 0, we still have 2. That means our v prime s equals to 2. Now, we can now apply the formula. Let us now, using the formula we have, we say f1 of s equals to u of x dot v prime x plus v of s dot u prime x. Now, to solve this, we now say that what is our u? Our u is 3s raised to power 4, 3s raised to power 4, dot, meaning multiplication. V prime s, which is 2, we now have plus v of s 2x minus 5 dot u prime s, this is our u prime s, 12s raised to power 3, which equal to 3 times 2 here will give us 6s raised to power 4 plus here 12s raised to power 3 times 2, 24s raised to power 4 minus 12 times 5, 60, we have s raised to power 3. What is our final answer here? 6s raised to power 4 plus 24s raised to power 4. There, since 6 and 24 raised to the same power, so we are permitted to add them together. We now say 6s plus 24 equals to 30s raised to power 4 minus 60s raised to power 3. This is f by x answer. That is our answer for that. We move to quotient rule. We move to quotient rule. Under quotient rule, what do we have? We say quotient rule. How do we solve question under quotient rule? What is the formula to be used? The formula to be used in quotient rule is f of s equals to, you write down the formula saying this started with u, this started with v of s, the v of s dot u prime s minus u of x dot v prime s divided by v of x raised to power 2. This is the formula to be used under quotient rule. Let's take a question. E.g. 6. The question says that given f of s, given f of s equals to 5s raised to power 3 divided by 4s plus 3. Find f prime x. This is the question. Now we want to solve this question. We say solution. Given f of x equals to, we see that its quotient is in division. Now 5s cubed, which will be our u. First thing we need here is to know what our u is. Our u is the denominator here. We have the denominator here, the numerator here. 5s cubed, denominator 5s cubed, and our v equals to 4x plus 3. Now, u prime s equals to, we have 5 here. This 3 will come here to be in bracket 3 s raised to power 3 minus 1, which equals to 5 times 3, 15. S, 3 minus 1, 2. That will be 15s raised to power 2. Here, v prime s equals to, under first order condition, we have 4s. This 3 is constant. It becomes 0. Here, we now have 4s in bracket 1, s raised to power 1 minus 1. Why this one will be plus 0, which equals to 4 times 1, 4x, 1 raised to power 1 minus 1, 0, which equals to 4 in bracket. S raised to power 0 is what? 1. 4 times 1 equals to 4. We move ahead. Now, let's solve for what? Let's solve for our f prime x. We now say f prime s equals to, using the formula v, our v here is what? In bracket 4x plus 3, bracket close, dot, that is multiplied by u prime s, which is 15s raised to power 2, minus, we now have minus u of x, u, 5s raised to power 3, in bracket v prime s 4. which equals to 4, divided by v of x raised to power 2, 4x plus 3 raised to power 2. Our f prime x equals to 15 times 4 here, 60, x raised to power 2 times x raised to power 3, which equals to 60 x raised to power 3 plus 15 times 3, 45 x raised to power 2 minus 4 times 5, 20 x raised to power 3 divided by bracket open 4x plus 3 in bracket raised to power 2, which equals to anyone that is in the same power, yes, 60 and 20. 60x cubed minus 20x raised to power 3. What do we have? We have 40x cubed plus 45x raised to power 2 divided by 4x plus 3 raised to power 2, which equals to, now, f prime s equals to 40x raised to power 3, 45. 8 is, what is common in both? 5. 5 in bracket, 5 in 40, 8. S raised to power 3 plus, here we give us 9. Now, we have what is common in both. 5s raised to power 2 is common in both. In bracket, 5 in 40, 8, remaining 1 x, plus 5 in 45, 9, no x. Then we have 4x plus 3 raised to power 2. Final answer. Thank you. So, that is our final answer here. Another thing we have to take a look at is what we call generalized power function rule. Is what we know as generalized power function rule. In generalized power function rule, how do we solve question on it? Under generalized power function rule, for instance, if you are given, e.g., if you are given something like f of s equals to bracket s cubed plus 6 bracket raised to power 5, find f prime x. How do we solve this? In this kind of question, under generalized power function rule, s cubed plus 6 in bracket raised to power 5, how do we solve this kind of question? The first thing you will do here is to do what? What is your u? What is your u prime? What is u? U of s equals to s cubed plus 6. This is your u. If this is your u, then what do? U prime of s equals to what? 3x, when you call it 3x, 1 minus this 3 will give us 2, and this one will go off because it's constant. So you have 3x raised to power 2. Now what is the formula we use? The formula for generalized power function will say f prime s equals to n in bracket u s bracket close n minus 1 dot u prime x. This is the formula. Then what is our n? Our n equals to 5, which is